Hi everyone, we're looking at notes 1.4, which are on applications of trigonometry. So before we do anything at all, we need to look at two important vocabulary expressions, the angle of elevation and the angle of depression. So the angle of elevation is going to be when you have a right triangle right here. This angle right here is called the angle of elevation. Now, a lot of people will get confused because they'll think the angle of elevation is up here because elevation means high. But it's called elevation, this is called the angle of elevation because it is elevating as we move through the triangle. So it's where it's increasing or going up, okay? Now, the angle of depression is also one that people get a little bit confused by because, again, they'll think if this is the angle of elevation, then this is the angle of depression. But this angle right here is nothing. It has no name. The angle of depression is actually outside of your triangle right here. So this is the angle of depression. Okay? But one thing I want you guys to be aware of is using the Z pattern. If you remember the Z pattern, this angle is equal to this angle down here, which happens to be the angle of elevation. So the angle of elevation and the angle of depression are the same measurement always, okay? I can't stress this enough. This angle up here is nothing. It doesn't mean anything at all. It doesn't have any specific name, okay? So the next thing that we see is a question that says, what should you do when solving trigonometry application problems? So the first thing that we need to always do is we have to draw a picture because there's no way we can see what's going on without having a visual of it, okay? And that includes labeling sides as well, okay? And angles, okay? Determine whether you're finding an angle or a side, okay? Then determine the trig ratio you need. And then lastly, if you're finding an angle, don't forget to use inverse sine, inverse cosine, or inverse tan. Okay? All right, so let's go ahead and take a look at question number 1. In number 1, it says the angle of elevation, so we're going to underline key terms, from a point 36 feet from the base of a tree on level ground to the top of the tree is 22 degrees. And we want to calculate the height of the tree. And it's to the nearest hundredth, okay? So I'm going to draw a picture of what's happening here. So here's my tree, okay? Here is the base of my tree, and there's a point that's 36 feet from the base of the tree. So here's my point that's 36 feet from the base. And since this is the base right here, then this is going to be 36. And it says the angle of elevation is 22 degrees. And I need to calculate the height of the tree. This is the tree, so I want to figure out what that x is right there. So now, right here, I know that this x is the opposite because it's across, and I know this 36 is the adjacent because my right angle is here, so that has to be the hypotenuse, okay? So we'll write out SOHCAHTOA, and the trigonometric ratio that uses opposite and adjacent is tangent. So I'm going to write out the tangent of my angle, which is 22 degrees. So we need to determine if we're finding an angle or a side. We know we're finding a side. We need to determine the trig ratio. We found out that it was tangent. And tangent is opposite over adjacent. So in order to get this x alone, I can multiply both sides by 36. So x is equal to 36 times the tangent of 22. So I'm going to go ahead and go to Desmos right here, and I'm going to click on the scientific calculator, and I'm going to type in 36 times the tangent of 22. Okay, press enter. I get this answer here. It asked us to round to the nearest hundredth, so the first 4 is in the hundredths place. The second 4 after it tells us to keep this 4 the same. So here we're going to just say x is equal to approximately 14.54 feet. And that's the height of the tree. Okay? Okay, in number 2, it says a man at the top of a cliff looks down at a pond. The cliff is 25 meters in height. So first of all, let's go ahead and draw in our man and our pond. So we've got a man who's at the top of a cliff, and he sees a pond, and the cliff is 25 meters in height. Well, we should probably underline this key information. And the angle of depression from the top of the cliff is 30 degrees. So this is where we need to be really careful about how we label in our angle of depression. Okay? Find the direct distance between the man and the pond to the nearest meter. So right here, I'm going to put a right angle right here. We want to find the direct distance between the man and the pond. So this is what I'm trying to figure out. And it tells us that the angle of depression is 30. So when I draw in right here that this is 30 degrees right here, it should be good to go. Now, this is outside of the triangle, so how does this help me out? Well, I know that we have another right angle here, so in order to figure out what this angle inside of here is, I'm just going to subtract 30 from 90 degrees. So we know that this angle right here is 60 degrees, okay? And we know that this is the adjacent because it's next to it, and we know this is the hypotenuse, okay? So let's go ahead and write out our trig ratios. Leave a little bit of space because I'm going to show you something else on this side right here, okay? And we're going to use cosine because cosine uses adjacent and hypotenuse, okay? So I'm going to say the cosine of 60 degrees is equal to the adjacent, which is 25, over the hypotenuse, which is x. And I'm going to make this over 1, and I'm going to cross multiply. Okay, so here, x times cosine of 60 is just x cosine of 60. On this side, 1 times 25 is 25. I'm going to divide by the cosine of 60 on both sides to get that x alone. Okay, so x is equal to, I'm going to type this into my calculator, 25 divided by the cosine of 60, and press enter, and I end up getting 50. So I know that the answer to this question here is going to be x is equal to 50 meters. Okay, but I want to show you guys another option that you have to solve a problem like this. Okay, so again, we had that this was 25. Okay, let's just split this down the middle here. This is 25 meters. We want to figure out what this x is right here, and we knew that this angle up here is 30 degrees. Now remember, using the Z pattern right here, we can also say that this angle right here is also 30 degrees. So if we use this angle here, if this is 30 degrees, this 25 is the opposite. This x is the hypotenuse. So this time we would use sine because sine uses opposite and hypotenuse. So here I would say the sine of 30 is equal to the opposite, which is 25, over the hypotenuse, which is x. So I'm going to cross multiply again. So here, x times sine of 30 is x sine of 30, and 1 times 25 is 25. So I'm going to divide both sides by the sine of 30. Those cancel, so x is equal to, let's go ahead and type that in, 25 divided by the sine of 30. And I still end up getting 50 as my answer. So you have two different options when you have an angle of depression. The only option you do not have is to put 30 degrees in this spot right here, because that is mathematically incorrect. Okay? Now, for number 3, 3 is very similar to number 1, so I'm not going to make a video for question number 3 or include it in the video. You are more than welcome to try it on your own, and I can check it for you if you feel like you need more practice, or if you feel comfortable with it, you can just skip it altogether, okay? Okay, number 4, it says a helicopter sights a campfire at an angle of 40 degrees from the horizontal. So we see, so we're going to draw in a picture of our campfire. Now, drawing is not my strongest suit, so please don't judge me. This is our campfire right here. We're going to draw our helicopter over here. This is my best attempt at a helicopter. And we have our right triangle right here, okay? So it says that the helicopter sights a campfire at an angle of 40 degrees from the horizontal. Now, since it's from the horizontal and the helicopter is up here, we'll put an H so you know that's the helicopter, then that 40-degree angle is up here again, okay? And the helicopter is hovering 400 meters above the ground. So since this is the ground, the 400 meters is the vertical piece right here. What is the horizontal distance between the helicopter and the campfire? Since it's the horizontal distance, this X is what we're trying to figure out right here, okay? Now, you have two options. You can either determine this angle up here, or you could say this is 40 degrees over here, and then you wouldn't have to calculate this angle up here. These are equal to each other using the Z pattern. So I'm going to figure out this angle up here by subtracting 40 degrees from 90. So this angle is 50 degrees over here. We know that X is the opposite, and we know that 400 is the adjacent. So using SOHCAHTOA, I have to use tangent because tangent uses the opposite and the adjacent. So the tangent of our 50-degree angle is equal to the opposite, which is X, over the adjacent, which is 400. So to get the X alone, I just simply have to multiply both sides by 400. So X is equal to 400 times the tangent of 50. Okay, so I'll go ahead and type that into my calculator. So 400 times the tangent of 50, and that's my answer. It asks us to round, or it doesn't say what to round to, so let's round to the nearest whole number. We get approximately 477 meters here. So X is equal to approximately 477 meters. So we can say here, therefore, the horizontal distance between the helicopter and the campfire is 477 meters. Okay? Okay, question number 5 says, a sailboat that is 2 kilometers due east of a lighthouse sends a signal to the lighthouse that is in distress. The lighthouse quickly signals the Coast Guard that is due south of the lighthouse and 7 kilometers southwest of the sailboat. What heading from due north should the Coast Guard take in order to intercept the troubled sailboat? So let's go ahead and talk about how to do this right here. So first of all, we have our lighthouse right here, okay, and we have our sailboat over here, and it says that it is 2 kilometers due east. Due east means directly east, okay? The lighthouse signals the Coast Guard that is due south of the lighthouse. So here we know that this is the Coast Guard, and it is due south of the lighthouse. Sorry, we'll put Coast Guard right here. And 7 kilometers southwest of the sailboat. So sailboat to the Coast Guard, you have to go southwest right here, and this is 7 kilometers, okay? What heading from due north should the Coast Guard take in order to intercept the troubled sailboat? Since we're trying to find the heading from due north, right here, this is north, this is the angle that I want to figure out. So to figure this out, I know that the 2 is the opposite from this angle, and I know that the 7 is the adjacent. So using SOHCAHTOA again, I know that I'm going to use tangent because tangent uses opposite and adjacent. This time, I don't know the angle, so I'm going to say the tangent of x is equal to 2 over 7. Remember, this is not saying tangent times x. This goes together. It's the tangent of some angle. So to get this x out of here, we have to do the opposite of tangent, which is inverse tangent. So we're going to do the inverse tangent of 2 over 7. So x is equal to, let's go ahead and type that in. So inverse tangent, we'll go to function, inverse tangent of 2 over 7. Okay, we'll close our brackets here and then press enter. And our answer here is going to be 16 degrees. So here, x is equal to 16 degrees. So therefore, the Coast Guard should travel 16 degrees from due north. All right, guys, one last one and then we're done. Okay, number 6. Safety bylaws state that for a ladder to be stable, the angle of the base of the ladder that makes with the ground should be between 70 and 80 degrees. A safety inspector at a construction site notices a painter on a 10-meter ladder that is leaning against a wall. So let's go ahead and draw a picture of what's happening here. Here's our wall. Okay, here's our ladder, and it's 10 meters. Okay, and the base of the ladder is 1.5 meters away from the wall. Does the inspector have cause to be concerned? So again, the angle of the base of the ladder right here that it makes with the ground is the angle that has to be between 70 and 80 degrees. So to figure this out right here, we know that this 1.5 is the adjacent, and we know that this 10 is the hypotenuse. So using SOHCAHTOA, adjacent and hypotenuse would be cosine. So we're going to say the cosine of x is equal to 1.5 over 10. Now, since we're trying to find the angle itself, we're going to use inverse cosine of 1.5 over 10. So let's figure out how big this angle is going to be. So x is equal to inverse cosine of 1.5 over 10 right here. And we end up getting approximately 81.4. This 3 will bump up to a 4 because of that 7. So we know that this is going to be 81.4 degrees. But it's only allowed to be between 70 and 80 degrees. So this angle is too large. So does the inspector have cause to be concerned? Absolutely. So therefore, the inspector has cause to be concerned because the angle is 1.4 degrees larger than what is allowed. Okay, and that's it for this question. Let me know if you have any questions, and I hope you have a great day. Bye.